Hey everyone, welcome back to our NumPy series. Today we are diving into one of the NumPy's most magical powers, which is broadcasting. Now, let's start with something you might have already seen. So here we have two arrays. One is of the size 3 cross 3, another one is a one-dimensional array. It has three elements. So this is the shape of this array. Now, if I were to apply a element-wise plus operation on this, what will happen? What do you think will happen? So this worked, right? It did not raise any issue. But Python list would have raised an issue if you would have tried to do the same thing, but with the Python list, you would have got an error. But with NumPy, it just works. So what's going on here? Let's see. So what you just saw in action is called broadcasting. Broadcasting is NumPy's way of making shapes match automatically, so that operations like addition, subtraction, or multiplication can work even if the shapes are not the same. So imagine NumPy saying, okay, this array is smaller. I'll stretch it logically to match the bigger one. Once I've stretched it, I can do the element wise operation. And that exactly is what broadcasting is. Now, broadcasting doesn't actually copy the data, it pretends to copy, which saves the memory. Now let's understand this with a previous example. We had two matrix, one of size 3 cross 3, another one was of size 1 cross 3. Now let's see how B, the smaller matrix, is broadcasted to match A. So this is what happens. Then we do A plus B, and this is the output that we get. Element wise addition operation is applied on the two matrix. That's broadcasting in action. Now, are there any rules of broadcasting? Of course, there are. There are certain rules, but the best part is you don't need to memorize these rules. They're logical, so if you understand shape alignment, you need not to memorize these rules. But this is how the rule goes. We compare the shapes from right to left. Then we check if the two dimensions are compatible. How do we know if they are compatible? If they are equal, that means they are compatible, or one of them is 1. And if one array has fewer dimensions, NumPy pads it with ones on the left. So let's understand this with an example. So let's say we have two matrix NumPy arrays. One is 3 cross 3, another one is a one-dimensional array with 3 items. Now, on the right-hand side, because we go from right to left, one item is 3, another one is 1. So this is fine for broadcasting. And if you look at the leftmost item, they are same, 3 is equal to 3. So this is okay to be broadcasted. So if you apply any operation, element-wise operation on NumPy arrays of these shape, it will go through. What about this one? Again, this is okay. Why? Because in this case, when you compare 1 and 4, one of them is 1. So this is fine. 3 and 1, again, one of them is 1. So both these arrays would be stretched and broadcast to an array of size 3 cross 4, and then the operation would be applied. What about this one? Same story, 3 and 1. So this is again okay to be broadcasted. What about this one? 2 cross 3, 2 cross 4. So when you compare 3 and 4, they're not equal and one of them is not 1. So both the conditions are false. So this one cannot be broadcasted. This will give you an error when you try to broadcast it. Now let's go back to our Jupyter notebook and understand this with some examples. So here we have two arrays. And these can be broadcasted based on the previous condition. And the final broadcast shape is 3 cross 3. Now let's look at one more example. This one, I'm sure you must have used it before without realizing it is actually broadcasting in action in the background. Now here you have an array and you're multiplying it with a scalar 5. Now this, when you run this 5 is multiplied with all the items here in our array. So what is going on? This is scalar broadcasting. 5 is treated like this. The scalar 5 is treated like this. Let's take one more example. Will this go through if you apply some element-wise operation? So if you look at the shape of M, that's 2 cross 3. What about the shape of column variable here? That's 2 cross 1. So that means this can also be broadcasted. Now, because the column shape is 2 cross 1, it gets stretched across the row dimension. So what we get in the row, it will look something like this. So 10 cross 10 cross 10 and 20 is 20 cross 20. So in the background, it would be broadcasted like this. And then whatever operation that you apply would get applied. Let's quickly check the shape of this as well. Okay, there is this bracket missing. So 2 cross 3 is the shape. Now, if I say M plus column, let's do it right here. It should run just fine. And this is what we are getting 10 plus 1, 10 plus 2, 10 plus 3, and 20 plus 4, which is 24, 20 plus 5, 25, and 20 plus 6, 26. Let's take an example where the broadcasting fails. So you see, this 3 is not equal to 1. So here, 3 is not equal to 2, and neither is 1. So that means these two arrays are incompatible. So when you try to apply any operation on these two arrays, element-wise operation, it will give you an error. It will give you an value error saying operands could not be broadcast together with these shapes. So that's on broadcasting. A quick recap. Broadcasting, we have seen, stretches smaller arrays logically. It matches the dimensions from right to left. It is compatible. We say two arrays are compatible if they are equal or one is one. And you don't have to memorize it. That's very important. It's intuitive, right? Once you start visualizing the shapes, you think on lines of whether you could, apply the broadcasting without making any assumptions. If it can be done, NumPy will do it. If assumptions have to be made, stretch it, then of course it will not go through. You will get a value error. So avoid memorizing, understand the why. So that's all for this video. Thank you for watching.